All right, going to work out the section 4.7 review for you. I'm going to pause the video whenever I punch stuff in the calculator just to speed it up a little bit. This first triangle, notice this is a right triangle. When we're solving for x, y, or z, or any piece of a right triangle, you can go with old-fashioned trig functions. If you want to use SOHCAHTOA or law of cosines, that will work. But I'm going to make this a little bit easier and channel my geometry skills. Y'all remember being in 10th grade? Or 9th grade for some of you. I think the easiest one to solve for is going to be y, because that's just straight up Pythagorean theorem. So I'll do 3 squared plus 8 squared equals y squared. 3 squared is 9, 8 squared is 64, 9 plus 64 is 73, and we get y to be the square root of 73. There is no need to punch that in the calculator. It's not going to help you one bit, so we'll just leave that as the square root of 73. You could also set up law of cosines with that if you wanted, but that's not really going to be needed. This is much easier. Okay, solving for either x or z, doesn't matter which one you solve for first. Let's just start with z. When I solve for z, this is a right triangle, so that means I could use SOHCAHTOA opposite over hypotenuse or something like that. I prefer to use the given information. I have an 8 and a 3 that was given to us. So I would prefer to use those two. And when I'm looking at z, 8 is the opposite and 3 is the adjacent. So solving for z, I'm going to say the tangent of z is my opposite side length of 8 over the adjacent side length of 3. And then z would be the inverse tangent of 8/3. And I'm going to punch that in the calculator in just a minute. I'll come back and do that. Then solving for x, I'm going to use 3 and 8 again. And again, 3 is, that's the opposite and the adjacent. But with x, if I do the tangent of x, then, I'll do this in blue. Then my opposite side is now 3. So tangent of angle x is my opposite 3 over the adjacent 8. And to solve for x, we will do the inverse tangent of 3/8. And we'll punch both of those in the calculator. I do prefer these answers to be in degrees. I typically like radians, but for this section and on this test, let's keep our calculators in radians. In degrees. All right, there we go. So that's what we get for z and x. Something else you could have done for x, once you get z, you would have two angles. You would have 90 and 69.444. You could subtract those two from 180 to get x, and you would get the same answer. It really doesn't matter which way you do it, as long as you get the right answers, and you're not cheating. Not your good for nothing. All right, let's try number 2. Now 2, while it looks like it's a right triangle, we don't know that. Since this is not a right triangle, that means what we just did for number 1 is off limits. For this problem, we will have to use either the law of sines or cosines. And in this case, you cannot use the law of sines because we don't have any angles. All we have is side lengths. So we're going to use the law of cosines. If you remember with the law of cosines, you choose an angle and its opposite side. It really doesn't matter where you start. Let's just go in order. Let's solve for x first. And I'm going to do x, and 6 is opposite x. So when I set up the law of cosines, 6, the one that's opposite the angle you're using, is by itself. It's going to be 6 squared equals 5 squared plus 2 squared minus 2 times 5 times 2 times the cosine of my angle x. And then we start working that out and cleaning it up. So 36 equals 25 plus 4 minus 2 times 5 is 10 times another 2 is 20. Cosine x, 36 equals 29 minus 20 cosine x. The biggest mistake people make on the law of cosines is right here. They're tempted to do 29 minus 20 and say 9 cosine x. You cannot do that because 20 is multiplied by cosine, and you have to multiply before you can subtract. So what I'm going to do is subtract the 29. Subtract 29. That gives me 36 minus 29 is 7 equals, those cancel right here. Leave me with negative 20 cosine x. Divide by negative 20. Get 7 over negative 20 equals the cosine of x. And when you're solving for an angle, if you want to separate the x from cosine, when you're looking for an angle, you have to do the inverse trig function. In this case, it's inverse cosine. of 7 over negative 20, and we will throw that in the calculator. All right, so I threw that in the calculator. I got 110.487. All right, so I got 110. Something I was thinking about, I told y'all when you use the law of sines, if you have the option to solve for the smallest angle first, with law of cosines, it doesn't matter. I chose the largest angle, but not because it was large, it was because it was x. I wanted to go in order x, y, z. With the law of cosines, it doesn't matter which angle you choose. With the law of sines, when you have the option, you want to choose the smallest angle first. And that's actually going to come into play right now because I know that x is approximately 110. Let me erase that. I'm going to say x is in the vicinity of 110. Now, I'm going to be using that angle, so I did store it in my calculator for a. And the thing I'm going to solve for next, now that I have an angle, that opens up the door for law of cosines, the law of sines. And when I solve using law of sines, when I have the option, I'm going to solve for the smallest angle first. So I'm going to solve for y, which is opposite 2. That's my shortest side, so I know y is the smallest angle. And I'll set up law of sines doing sine of y over 2 equals sine of 110 over 6. So let's solve for y. So sine of angle y over 2 is going to equal the sine of that angle I just solved for over 6.
Alright, this is where I paused the video and turned off the microphone and then came back to record and forgot to turn on the microphone again, so I'm now giving a play-by-play and I'm about to come back and solve this. 110 degrees I did store for A, so when I plug this in the calculator I will hit alpha A. And there's my work, and you see I got 18.195 for B. And not sure what I'm doing there. Oh, I know what I was doing. Pointing out that anytime you write a sine, cosine, or tangent, you have to make sure you put an angle inside it. You have to do, like when I write sine or cosine, I had to say sine of x or sine of y or cosine of x. You cannot do the sine of a side length, say sine of 2, wouldn't make sense in this problem. Because 2 is a side length and not an angle. So just make sure that anytime you write sine or cosine or tangent, you have to put an angle in it. And then once you get all of your angles, you can subtract from 180 degrees, and that's where I got z down there. So here you are looking at number 3. This one's going to be another law of sines problem. I see 72, and opposite 72 is 5, so I'm going to use those two as much as I can. And the only other variable I can solve for in this problem would be y. So here I am finding y and its opposite side, and we're going to set up the law of sines using that. I cannot solve for z or x because both of them are variables. We'll have to come back and solve for one of those later. So here I am setting up for y. The sine of y over 2 is equal to the sine of 72 over 5. And I'll cross multiply this. I am trying to solve for an angle, so I'll end up doing the inverse sine at some point. So here I'm 5 times sine y equals 2 times sine 72. And I'll work this out real quick. Kapow! Told you. And when I punched it in, I got 22.360. And that's what I got. I did store that for A. Anytime I get a decimal answer that's not pretty, I'll store it in my calculator. And then the thing you need to remember is to first make sure your answer makes sense. 2 is smaller than 5, so since 2 is smaller than 5, I expect the angle opposite 2 to be smaller than the angle opposite 5. And it is, so 22 makes sense. But anytime you do the law of sines, and this is the pesky part, you have to think about that second possible triangle. So I get 22.360, or y could be, and the second possible answer for y is 180 degrees minus the answer you just got. So I would punch that in the calculator, 180 minus a, and I get 157.64. And 157 definitely will not work because 157 is bigger than 72, and for y, I have to get an answer that's smaller than 72. So even though we think about it, we have to make sure that we check it's how reasonable it is, and this one just doesn't work. So we scratch it out, and this is good because now we only have to deal with 22.360 for y, and I will now continue to solve for z and x in that order, because now that I have a triangle with two angles, I will find z, and there it is, 180 degrees minus 72 minus the answer that I have stored for a, and I got 85.64. And then I will set up to solve for x, and the only way I can solve for x is the law of sines. So I'll set up sine of that angle over x, and that would have to equal I'm going to use sine of 72 and 5 because that's given information, and those are nice whole numbers. You don't have any crazy decimals. So let's use sine 72 over 5 and sine of 85.64 over x. Just remember that when I punch in 85.64, I do have that stored in my calculator for b, so I will simply hit sine of b when I need that part. So here we are cross multiplying. We'll work out the problem, and there we are for x. I got 5.242, and as always, check to make sure that 5.242 makes sense. It is opposite the largest angle, so I got the longest side length. 2, my short side length of 2 is opposite the smallest angle, so this triangle makes sense. My large angles are all in the right spot. One thing you need to remember is when you're trying to cancel, when you divide to cancel the sine 72, the whole thing cancels. Do not try to simply cancel the sine or just the 72. Sine 72 is treated as one big thing, so you have to cancel the whole thing at once. So here we are, number 4. This looks kind of like the same setup as that last problem. I have 60 degrees and 4. They're opposite each other, so I like that pairing. And then the only other one I could solve for is x, so I'm going to set up sine of x over 5 and sine of 60 over 4. So setting that one up. Cross multiply, and we get, whoa, that's a whole lot of movement there. Let's see, I got something goofy in the calculator right here. Notice when I punched this in, I got undefined returned on my calculator. So when I get an answer like that, I always check and make sure that it wasn't my mistake first. So I'm looking back, and as soon as I see that undefined, I know to check for errors. And I should have the inverse sine of 5 sine 60 over 4, and that's what I'm checking here. And I did plug it in correctly. And since I plugged it in correctly, the next thing I'll look for is to make sure that my calculator is in degrees instead of radians. And down there I can see that I am in degree mode. If you're in an 84, you're going to have to hit the mode button and check it that way. But since I am in the correct mode, I did punch everything incorrectly. Then what this means, since the calculator returned an error, it just simply means this is not a triangle. You cannot possibly draw a triangle with these dimensions. It would not connect. We'd have a disconnected triangle. So you can write not a triangle. You can write no solution. You can draw a picture of Triangle Man throwing things at me because I gave you a stupid problem that doesn't work. Just some acknowledgement that this problem blows up on you. And that would be good. This is a good thing because now we're through. We don't have to bother solving for y and z because y and z don't exist. This triangle does not exist. Problem number the last, not number the last, is number 5. What am I thinking? All right, let's see. Looking at this one, notice the side lengths and the angles are in a little bit of a different orientation. I have 48 degrees, and opposite 48 is a variable. This is a side angle side triangle. The two side lengths, 5 and 2, and the angle between them was given. You cannot do the law of sines on this one because it doesn't matter which angle and side pairing you choose, you will always have a variable. So law of sines is going to fail here. We're going to have to go with the law of cosines here. So we identify the angle and the opposite side. Since y is opposite the angle, y is the side length that goes by itself on the left side of the equation. And so y squared equals, and then it'll be 2 squared plus 5 squared minus 2 times 5 times the cosine of 48. And then since all of my numbers are on the right side, there are no variables on the right side, I'm going to take all of that and I'm just going to throw it in my calculator in one big swoop. You could piece it together and work out every little piece. If you remember number one, that's actually what we did because we had a variable on the right side. We didn't have an option. But for this problem, since y is already by itself on the left side, I went ahead and threw it all in the calculator, and there you see I did it. And you get y squared equals 15.67. I took the square root of that answer, and that gave me my angle A, which is my angle A. That gave me my side length of y, which I stored for A. And now that I have that side length, the option for the law of sines opens up because I still need to solve for x or y. So to solve for x or y, I'm going to use the law of sines. And if you remember, I told you that if you use the law of sines and you have an option, you want to try to solve for the smaller angle first. So I'm looking at my two side lengths. I have a 5 and a 2. Since 2 is smaller, the first thing I'm going to solve for is z. So I will set up this problem. Sine of z over 2 is equal to the sine of 48 over y. There we go. Sine of z over 2 equals sine 48 over y. And then I will cross multiply this. I am looking for an angle, so I will have to do the inverse sine. And I also have my answer for y stored for a in the calculator. So there I am cross multiplied, and I solved for z, and I got 22.092, and I stored that in my calculator for b. When you solve for the small angle, you don't have to worry about the second triangle, but if you wanted to try it out, oh, here I am checking the reasonableness of it. 2 is smaller than 3.9, so this z should have been smaller than 48, which it was, so I'm happy with that answer. The second possible answer, which you only use if you use the law of sines, if I did 180 minus 22, you get 158, which is way too big for angle z. So that doesn't work. And we throw it out, and we only have to solve for x, which now x is going to be easy because I just subtract my other two angles from 180, and that gives me something. Here it comes, 46.360, or is that 36 degrees? I think that's 360. I'm not sure what happens. Oh, that doesn't make sense. 46 doesn't make sense at all because x is opposite my large side. 5 is my longest side, so x should be my largest angle, and it's not. So I've done something wrong when I punched that in, and I'll have to plug that in again. And this is why I tell you to check to make sure your answers are reasonable. X is the largest angle, so 46 does not make sense. So we'll scratch that out, and we will try again. And that's why you always check to make sure your answers make sense. That was a problem where I made a silly mistake on the calculator. And simply by checking to see if the answers were reasonable, I knew that I should try again. And the actual answer for x is 109.908 degrees. There we go. I don't know what I'm talking about right now. By the way, I'm still doing a play-by-play. This is kind of fun. I guess I'm checking to make sure everything makes sense. So it did. All right, finally, number 6. Last problem, and this one's a little bit of a doozy, as you can tell, because there's still a decent amount of time left in the video. Let's see, I'm going to set up law of sines here because I do have an angle and its opposite side. So sine of 25 over 1 is equal to, and I'm going to have to solve for z because x and y are both variables and they're opposite each other. So sine of z over 2 and then I will cross multiply and I will solve those two equations. There we go. We got 57.697. I will store that for A. I did have to do the inverse sine because I was looking for an angle. But I used the law of sines to get an angle. I got Z by using the law of sines, which means I need to consider the second possible angle. So 57.697, it does make sense because 2 is bigger than 1, so z should be a larger angle, which it was. But I also need to consider a second possible answer for z, and you get the second possible answer by subtracting that answer, 57, from 180. And when I do that, I get 122.303, and that would be an answer for z. And, that one makes sense too. It's bigger than 25, and that's the only requirement we have for z. It has to be bigger than 25 because the opposite sides tell me that. So 122.303 is actually a second answer for z that I'm going to have to consider, and we're going to solve later. I will go ahead and store that in my calculator because I'm going to have to come back and use that later. We'll store that for b. And then what I'm going to do is when you have two possible triangles that both work, then we will take the second one right here, our second answer for z, and I'm simply going to put a little box around that, and I'm going to make a note to myself that we'll hold on to this until a little bit later. So put on hold till later, till after we finish our first triangle. So we pretend that 122.303 isn't even there, and then we go through and we solve the problem. So here's what I'm doing here is I'm going to copy that, and then I'm pasting it onto the next page because I'm going to have to come back and solve with that second triangle after I solve the first one. So let's see. Okay, I'm going to place some eraser there. All right, that was exciting. So we're solving this one based on z being 57. Once I have z, x is going to be the easiest one to solve for. We'll subtract from 180. And I guess I'm punching that in my calculator right now. I get 97.303. And so there's my answer for x. I will store that in my calculator. For c, I've already used a and b, so I'll store that for c. And now that I have x, I can set up the law of sines to solve for y. And notice I don't have to worry about a second angle for x because I did not use the law of sines to get x. I simply subtracted from 180. The only time you have to consider a second angle is when you are using the law of sines to get an angle. So here I am now setting up for x. I'm sorry, setting up for y. We know that sine of 25 over 1 would have to equal sine of my angle x, which I just solved, over y. We will cross multiply, and then we'll throw that in the calculator. And we get y to be 2.347. And let's see, I'm labeling that. Let's make sure that that makes sense. X was about 97. 97 is my largest angle, so opposite 97 is my longest side of 2.3. 25 is my shortest angle, so 1, my shortest side, is opposite it. So always make sure that the triangles make sense in that way. Okay, so now that I've solved that one triangle, what I have to do is pretend that all of that isn't there, and we have to go and solve for the second possible triangle, where z is 122.303. So now we're going to work that problem out, completely ignoring the 57.697. So I'm going to scratch that out. And now we solve all over again with z being 122. So x, I'm going to solve for x the same way I did on the last problem, subtract from 180. So x is 180 minus 25 minus 122.303. And I do have 122 stored in my calculator, so I'll, in my calculator, just type in 180 minus 25 minus b, and that gives me an angle of 32.697 degrees. So there's my angle for x. Now that I have b and x, or z and x, I can set up the law of sines to solve for y. And I'm already thinking ahead. X is my middle angle, so I expect y to fall somewhere between 1 and 2. And you always need to be thinking of stuff like that because that's how you know whether or not something is reasonable. Um, so here I'm typing it in or writing it down. Sine of my angle x over y will equal sine of, and use 25 and 1. Use the given information as much as you can. Sine of 25 over 1. Then we will cross multiply and punch that in the calculator. We get y to be 1.278. That is what I was expecting. I should have gotten something between 1 and 2, and that's what I got. So I'm happy. All of my side lengths and angles make sense. And that is how you solve a triangle when you have two possible triangles. And it's kind of a pain in the rear end, but that's just how you do it. So just know whenever you solve for an angle using the law of sines, you have to remember to test that second